Hi, I'm Hallie, and welcome to Project Str-Eng. Lots of questions surround the structures in our world, such as who made them, how they made them, and why they made them. And Project Str-Eng is our attempt to find these answers by understanding structural engineering. In this episode, we're trying to understand factor of safety, but first, let's talk about history. Whether driving over the Manhattan Bridge or on a flight to the Caribbean, we've all asked something similar. Is this actually safe? What us civilians don't know is that all engineers calculate the safety of every object, from a tiny bolt all the way to a massive skyscraper, with what's called the factor of safety, or FOS. After centuries of attempt, success, and at times, detrimental failure over the course of the Industrial Revolution, engineers at the tail of the 19th century began unionizing and discussing on how to make civilian and worker life safer, especially as new technology continued to advance. The first scientific research contract from the federal government was issued to the Franklin Institute in Philly in 1830 to look into why steamboat boiler explosions were so rampant and figure out how to stop them. By the mid-20th century, safety practices, codes, and protocols became the primary duty of engineers to ensure ethical practice. And honey, it was about time. When it came to the FOS, it was a revolutionary calculation on how safe each aspect of a structure was. The standard equation is FOS equals maximum stress over working or design stress. For brittle materials, it is FOS equals ultimate stress over working or design stress. And for ductile materials, it is FOS equals yield stress over working or design stress. Essentially, the higher an FOS is, the safer it is. An FOS of 1 means the structure will fail immediately when the maximum load is reached. An FOS of less than 1 is totally unacceptable. Now I'll pass it off to Peyton with the interview.
Tell me about probability.
The topic is not quite probability, but you can just say factors of safety.
Okay. Tell me about factors of safety.
Sure. Factors of safety is basically the start and end of every engineering problem. It tells us generally how to keep people safe, how to make sure our designs are always conservative, and it gears everything in engineering, not just structural engineering. In structural engineering, it's quite simple. You always want to make sure that the resistance capacity is a factor of safety higher than the load that's going to be applied. Let's say all you need is this rebar to exactly equal the amount of load that you need to resist. But because of the consequence of failure and the probability of failure, then we may need to specify something like, this size steel for something that in reality this size steel could support.
So what are some things that would make this a safer, like would weather apply or?
Sure, so there's always these eventualities that play into the probability of something bad happening. So things like how material was installed or how it's manufactured. More importantly, sometimes what the consequence of that failure is. So if it's a slow failure that you can fix in time, then maybe that's yours. Then maybe it's not that big of a deal and you can probably keep the factor of safety low, so closer to 1. Okay. But if it's of concern, something that would risk public welfare, then it's typically a high factor of safety. So sometimes you can get factor of safety as high as 5 or even 10.
Okay, and what do those numbers mean?
The numbers are basically just a fraction, so it's factor of safety is just like the failure load. The factor of safety is basically just a ratio. It's like the failure load divided by what the applied load is. Formula? So the factor of safety should always be greater than 1. Okay. And depending on how bad the consequence of failure and how common the probability, it gets bigger and bigger. Okay. That's pretty much all you need to know. Last one just for fun. Thank you much.
And how do we use that in everyday life?
So if it's used properly, then we don't see it at all, because you won't see things like failures. But yeah, it kind of guides all design principles, and depending on how high the factor of safety is, the more costly it is to build things, or the more precautions that surround it. Does that make sense?
So what is a disastrous thing that's happened where maybe someone or a colleague messed up the factor of safety and something crazy happened?
Nothing crazy. I mean, I've only been doing this for 5 years, and you can ask me when I'm, 55, see if the answer is the same. Nothing. But we have used some pretty high factors of safety in our design sometimes, which kind of seems excessive almost, but it's required by law. So for example, if I'm lifting something that's carrying one paton, like one person, then the factor of safety is 10, which seems like...
So you should be able to carry 10 patons?
Before it breaks, yes.
Before it breaks,
but we're only allowing one paton to actually ride in the lift.
Okay.
So sometimes the factors of safety seem quite large, but they're there for a good reason. Factors of safety can come about from a whole bunch of different reasons. Sometimes it's lobbying. So if somebody in the concrete industry wants to pay a lot of money, sometimes they can get their factors of safety reduced slightly by doing research or other kinds of things.
Okay, and so does that mean the cost of materials for them is cheaper, so they want to have the factor of safety be?
The amount of material would reduce. Factors of safety is kind of like the general term that all types of engineering use. In structural engineering, we mostly talk about the limit states design or allowable stress design. And basically, those things are two of the same, more or less. The equations are slightly different, but one of them puts a limit on the material and the load, and the other one just puts a factor of safety on the load. So it's two ways to get the same, more or less the same answer and the same amount of security, but different formula.
So after learning about the factor of safety, do you find yourself thinking about if you go into an elevator, how much of you it can carry or anything like that?
Yeah, if you see the loads posted, those are allowable loads. So if it's no more than 5 patons on this elevator, then you can think, okay, well, it's probably good for 20 patons. Okay. That said, it's not an advisable thing to do because these things see wear and tear and maintenance, and they may not have been installed with all the care
that art engineering would put into.
There you go.
Well, I won that one.
Yeah, that didn't work. Bang!
So basically, factors of safety are used to compensate for 5 different types of failure. 1, higher loads than those foreseen. 2, worse properties of the material than foreseen. 3, imperfect theory of the failure mechanism in question. 4, possibly unknown failure mechanisms. And 5, human error in design or calculations. The first of these 2 can in general be classified as variabilities, whereas the last 3 belong to the category of genuine uncertainty. Generally, a factor of unity, 1 or less, is applied to the resistances of the material and a factor of unity or greater to the loads. In determining the specific magnitude of the factors, more deterministic loads, like dead loads, the weight of the structure, and permanent attachments like walls, floor treatments, and ceiling finishes, are given lower factors, for example 1.25, than highly variable loads, like earthquakes, wind, or live, aka occupancy loads, around 1.5. Impact loads are typically given higher factors still, let's say 2.0. Does your brain feel bigger after this? I know mine does. Thanks for tuning in. Remember to smash that like and subscribe button on your way out, and as always, enjoy the process.
So what do you use these for?
Stick them in concrete. See the little ribs here? They kind of bind to the concrete and allow the concrete to transfer tensile stresses.
Do you just keep these in the trunk of your car?
No, Art keeps them here in case we misbehave.
Oh, okay. I was gonna